In the heart of New York City, under the shroud of a stormy night, the genius of Nikola Tesla simmered. Known as the Wizard of Electricity, Tesla's inventions would revolutionize the world. But amidst his groundbreaking achievements lies a creation shrouded in mystery and controversy: the earthquake machine. Nikola Tesla's story begins in the small village of Smiljan, in what is now Croatia. Born in 1856, young Tesla possessed an extraordinary intellect and a boundless imagination. His early life, marked by a fascination with the natural world, set the stage for a career that would change the course of history. Was a skilled inventor of household appliances, a talent that undoubtedly influenced her son. From his formative years, Tesla demonstrated an uncanny ability to visualize complex machinery in his mind, a gift that would lead him to the prestigious Austrian Polytechnic and beyond. His education and early work experiences in Europe laid the foundation for his eventual move to the United States, where his genius would truly shine. Upon arriving in America, Tesla quickly made a name for himself. He worked briefly with Thomas Edison, another giant of the electrical age, but their differing views on electricity, Edison's direct current, DC, versus Tesla's alternating current, AC, led to a professional rift. Tesla's eventual partnership with industrialist George Westinghouse enabled him to promote AC power, which would become the standard for electricity distribution due to its efficiency over long distances. Throughout his career, Tesla's contributions to electrical engineering were monumental. He pioneered the development of alternating current, AC power systems, which became the global standard. His invention of the Tesla coil showcased his remarkable ability to harness and manipulate electrical energy in ways previously unimaginable. This coil, capable of producing high-voltage, low-current, high-frequency alternating current electricity, became a key component in radio technology and many other innovations. Tesla was a man of endless curiosity and imagination. His mind was always buzzing with new ideas and concepts, some of which were so ahead of their time that they were often misunderstood or dismissed by his contemporaries. Among these revolutionary ideas was the concept of wireless energy transmission. Tesla envisioned a world where power could be transmitted wirelessly over great distances, eliminating the need for cables and wires. His experiments in this field, particularly with the Wardenclyffe Tower, though ultimately unsuccessful, paved the way for future developments in wireless technology. Amidst the myriad of experiments in his New York laboratory, Tesla discovered a curious phenomenon: mechanical resonance. This principle, where an object vibrates at its natural frequency, would become the foundation of what he would later call the earthquake machine. Tesla's fascination with mechanical resonance led him to theorize that by tuning the frequency of vibrations to match an object's natural frequency, he could induce increasingly powerful oscillations. This concept formed the core of his mechanical oscillator. Tesla believed that if he could harness this principle, he could create a device capable of immense power, potentially with applications in construction, mining, and even energy production. In 1893, within the confines of his New York lab, Tesla embarked on an experiment with a small mechanical oscillator. His objective was straightforward: to create a device capable of generating powerful vibrations. Little did he realize, this experiment would soon spiral into legend. One fateful day, Tesla attached his oscillator to a steel beam within his lab. As he gradually increased the frequency, the vibrations began to match the building's resonance. To his astonishment and subsequent horror, the entire structure started to tremble. The walls shook, and furniture rattled as the vibrations grew more intense, creating a sensation akin to a minor earthquake. In a moment of panic, Tesla quickly dismantled the device. The building's occupants, oblivious to the cause, feared an earthquake. This incident would become the cornerstone of the earthquake machine legend. Tesla later recounted how police officers had arrived at the scene, only to find him calmly adjusting his machine. He reportedly explained that he was merely conducting experiments, but the authorities were skeptical. Following the unnerving incident, Tesla instructed his assistants to destroy the oscillator, fearing its potential for destruction. Yet, the story of that day lived on, growing into a blend of myth and reality. Over time, the tale of Tesla's earthquake machine became part of the larger narrative surrounding his life and work, often cited as an example of his brilliance and the dangers of unrestrained scientific experimentation. To truly grasp the implications of Tesla's earthquake machine, one must delve into the science of resonance. Every object has a natural frequency at which it vibrates. When external vibrations match this frequency, the object oscillates with greater amplitude. This principle can be observed in phenomena ranging from swaying bridges to shattering glass. In engineering, resonance is both a powerful tool and a potential hazard. Structures like buildings and bridges must be designed to withstand resonant frequencies caused by wind, earthquakes, and other forces. Tesla's oscillator, if scaled up, could theoretically amplify these effects on a grand scale. While his experiments showcased the potential to influence structures, the practical applications, and inherent dangers of such a device remain profound. For example, in construction and demolition, controlled use of resonance could help break apart materials or settle foundations. Conversely, if misused, such technology could cause unintended structural failures or even weaponized applications. Tesla's vision extended far beyond mere scientific curiosity. He dreamed of harnessing resonance to tap into Earth's natural energies, potentially providing unlimited power. His ambitions included transmitting energy wirelessly using resonant frequencies, a concept that led to the development of his famous Wardenclyffe Tower. Although this project ultimately failed due to financial difficulties and lack of support, it highlighted Tesla's forward-thinking approach to energy and technology. Contemporary scientists and historians strive to separate fact from fiction regarding Tesla's ideas. While some dismiss the earthquake machine as an exaggeration, others view it as a testament to Tesla's unparalleled ingenuity and foresight. Modern researchers have revisited Tesla's work on mechanical oscillators, exploring their potential applications in fields ranging from seismic exploration to medical devices. Some have even constructed replicas of Tesla's oscillator to study its effects and validate his claims. Despite his genius, Tesla's later years were marked by financial struggle and obscurity. He passed away in 1943, leaving behind a legacy oscillating between brilliance and eccentricity. In his final years, Tesla lived in relative seclusion, feeding pigeons in New York City and continuing to develop new ideas, many of which remained incomplete or unpublished. Tesla's influence on science and technology endures. His earthquake machine, whether a harbinger of future technologies or a cautionary tale of unchecked ambition, remains a fascinating chapter in the narrative of human innovation. Today, Tesla is celebrated as one of the greatest inventors and visionaries of all time, with his name immortalized in the electric car company, Tesla Inc., and numerous awards and honors in his memory. The earthquake machine epitomizes the enigma of Nikola Tesla, a man whose ideas danced on the edge of science fiction, yet whose inventions fundamentally shaped our modern world. Whether myth or reality, Tesla's earthquake machine challenges us to ponder the limits of human ingenuity and the endless possibilities of scientific exploration. It serves as a reminder that the pursuit of knowledge, while fraught with risks, can lead to extraordinary advancements and unforeseen consequences. As the story of Nikola Tesla's life and contributions unfolds, we are reminded of the fine line between genius and madness. Tesla's earthquake machine may forever remain a mystery, but it continues to inspire and challenge us to push the boundaries of what is possible. His legacy is a testament to the power of imagination and the relentless drive to explore the unknown, qualities that continue to fuel innovation and discovery in the 21st century and beyond. Tesla's work on mechanical resonance wasn't limited to his infamous earthquake machine. He delved into various other applications, always seeking new ways to harness the power of vibrations. He envisioned using resonance to transmit signals and energy wirelessly. This concept found a practical application in the early development of radio technology, where the principles of resonance are crucial for tuning and transmitting signals. Tesla's contributions to radio were overshadowed by others at the time, but his pioneering work laid the groundwork for modern wireless communication. Moreover, Tesla's ideas on resonance and vibrations extended into the medical field. He believed that carefully controlled vibrations could have therapeutic benefits, potentially treating various ailments. Although much of this work remained theoretical or experimental during his lifetime, the idea of using vibrations for medical purposes has seen a resurgence in recent years with technologies like ultrasound therapy and vibration therapy for muscle recovery. Tesla's influence even touched the world of seismology. His experiments with mechanical oscillators provided insights into how vibrations travel through different materials. These principles are essential in understanding how seismic waves propagate during earthquakes, contributing to the development of early earthquake detection systems and building designs that can withstand seismic activity. Despite the broad potential applications of his work, Tesla often found himself at odds with the financial and industrial powers of his time. Many of his ideas were deemed too radical or impractical, and securing funding for his projects was a constant struggle. His unwavering belief in the feasibility of his concepts, combined with his tendency to focus on multiple ambitious projects simultaneously, often left him in dire financial straits. Tesla's later years were marked by increasing isolation. He continued to work tirelessly, driven by an unrelenting quest for discovery, but his projects were often dismissed as eccentric or overly ambitious. Yet, even in his solitude, Tesla never ceased to dream. He envisioned a future where technology could improve the human condition in unprecedented ways, a world powered by clean, limitless energy, where information and power flowed freely and wirelessly across the globe.